All right, so this is my week 4 problem 2 video explainer. So in this example, we have a person wearing a dress, and that dress is being held up by some balloons, and we are given the mass of the balloons and the dress to be 0.4 kilograms. And I just drew a quick force diagram on the left, which shows the buoyant force and the gravitational force. So we're trying to find the volume of the balloons. So as we know, the buoyant force is going to equal to the density times the volume times the gravitational acceleration, which is also going to be equal to the mass times the gravitational acceleration. And putting everything in the form of density allows us to solve for the volume. So we know that the density of air is 1.2 kilograms per meter cubed, and the density of helium is 0.166 kilograms per meter cubed. So we're trying to solve for V. And we also know the mass and the gravitational acceleration being 9.8 meters per second squared. But for the density, for that value, we are going to be subtracting the density of helium from the density of air for this system. So after we plug the values in for the densities, for the 2 G's and the mass of the balloons in the dress, we can also notice that the gravitational acceleration values will cancel out on both sides. And solving for V, we're going to get that's going to be equal to the mass over that density that we calculated earlier. So after dividing those out, the volume of the balloons is going to be 3.868 meters cubed. And this just relates to some of the stuff we were doing this week in regards to fluids and density, just finding out the buoyant force and just some stuff like that. And the tricky thing in this equation was knowing how to end up deriving that density value, but otherwise it was pretty straightforward, and just had to use some of the equations that we learned in class. So thank you.